Dylan's TV and his entertainment center, because we're trying to figure out if his entertainment center is going to be big enough for his TV. So this is what we're figuring out. They tell us that Dylan's entertainment center has a rectangular opening for a TV. Me being the visual person that I am going to draw an opening. This is our entertainment center. The opening is 50 inches wide and 30 inches tall. The size of the TV is described by the length of its diagonal. So anytime you buy a TV, in order for it to be measured, this is what determines the TV's size. We are going to figure this out, which is the largest TV from the list that Dylan could fit into his entertainment center, and then we're going to explain. So we're going to explain using a CER. Here we go. So we know that we have a square, rectangle, and it is 30 by 50, but we want to figure out how big our hypotenuse is. In order to do that, we're going to do 30 squared plus 50 squared equals c squared. 30 squared is 900. 50 squared is 2500 equals c squared. Here we go. So 900 plus 2500 is 3,400 equals c squared. In order to find the square root of c, we have to take, or the square, in order to find c, we have to take the square root of 3,400. So C would equal, let's do the math. C would equal, sorry, I'm pulling out my notes. 58.3 inches. So that means that this is a 53.8 inch diagonal. If this is 53.8 inches, the biggest TV that we can fit in this spot is a 55-inch TV. Now we're going to explain that using a CER. So we are going to do exactly what it says. We're going to figure out the claim, evidence, and we are going to go ahead and figure out our what? How do you find a CER? You're going to figure out your reasoning. So if we look at our rubric, we are figuring out our claim. We're going to restate what's happening. We're going to give it evidence using math vocabulary, and we're going to justify our mathematical language with our reasoning. So let's just say what's happening in this problem. So we are looking for the size of Dylan's TV. In order to find, this is a capital I. In order to find the size of Dylan's TV, we must first find out what size the space is that will fit the TV. We used the Pythagorean theorem to solve for the hypotenuse of a triangle with that are 30 inches and 50 inches. We used a squared plus b squared equals c squared. We plugged in, substituted 34a, 54b, and solved for c. We found the square root of 3,400, and this gave us the length that we could use to fit our TV in. This means a 55-inch TV will fit in this space. Okay, here we go. So now we're going to do solving a real world problem using our Pythagorean theorem. So in the book, What's Your Angle, Pythagoras, Saltos and Peppers argue that their 12-foot ladder does not reach a temple roof as shown. What height does their ladder reach on the temple wall? We're going to round to the nearest tenth of a foot. So here we go. We know that the Pythagorean theorem is a squared plus b squared equals c squared. The information that we have is a and c. We do not have a b. We don't know what b is. So let's plug in 5 squared plus b squared equals 12 squared. 25 plus b squared equals 144. Subtract by 25 to solve this problem. Cannot write. B squared equals 119. Yeah. The square root. Oops, sorry. B squared equals 119. In order to find b, we have to take the square root of 119. So b equals 10.9 feet. We have to put it in feet because we're talking about feet, so we have to remember that that's how we're going to solve it. Let's look at our next one. So they want us to solve the area of the right triangle. They have the area of the right triangle, and now we're solving for the perimeter of the triangle. So here we go. So we know that the area of a triangle is area equals 1/2 base times height. I also like to write it like this. That way it takes away the whole fraction part of it, sort of, just a little bit. Okay, here we go. We know that the area is 26.46. We know that the leg is 6.3. We're trying to figure out this length, and then we're going to figure out this length. So the way that we do that is that we're going to plug in the area. Area is 26.46 equals the base. We're just going to call this the base, 6.3 times the height divided by 2. Well, if we do this problem exactly the way that we should, remember, we can do, undo. Okay, so here we go. Here is our h. This is what we're solving for. The thing closest to it is the 6.3. It's multiplying by 6.3. Then it is being divided by 2. So to do the opposite would be to multiply by 2 and then divide by 6.3. So we're going to multiply all of this by 2 and all of this by 2, and that is going to give us 52.92 equals 6.3 times h, because 2 divided by 2 just gives us 1. Then we're going to go ahead and do the next thing, which is divide by 6.3. And then if you do the math, you're going to get that your height equals 8.4. Remember, 6.3 times this equals this. So that's what we're solving for. So we know that 8.4 fits here. But now we need to solve for our hypotenuse. Here we go. So we now know a squared plus b squared equals c squared. 6.3 squared plus 8.4 squared equals c squared. 6.3 squared is 36.69. 8.4 squared is 70.56. We're going to add those together. That gives us 110.25 equals c squared. We now have to solve for c. Root of 110.25 equals c. So c is going to equal 10.5. But we're not done yet because it asks us for the what? The perimeter. So perimeter is all the way around. That means that we're going to add 6.3 plus 8.4 plus 10.5. And if you add that up, it's going to give you 25.2 units. Okay, here we go. So the last was focus question about thinking inside the box. And I'm going to go ahead and draw the box that we were looking at. There was a video of a box, and we were trying to figure out if a 32-inch bat could fit in a 20 by 20 by 20 box. So this is the question. If a 32-inch bat could fit in a 20 by 20 by 20 box. So I'm going to go ahead and just draw our box. So we have a 20 by 20 by 20 box. 20, 20, and 20. There we go. 20 by 20 by 20 box, and we want to know if a 32-inch bat could fit in the box. Well, the first thing that we have to do is figure out what is going to be our length of our box. So we need to look at how could we start solving this problem. So the way that I explained it in class was this. Right now you have the bottom of this box, right? And the bottom of this box goes like this, comes down here, comes across like this. So this is your box right now. There we go. That's better. This is your box. And we want to know what if this is a right angle, because it is. It's a box. This is 20. This is 20. What is this? So we got to figure out this part right here. So I'm going to highlight that for you. So this is the triangle that we're solving for right now is the bottom triangle. So if we have a 2D shape, this is the bottom of our box, and we have a 2D shape. That means that right now we're solving to figure out if we know that this is 20 and this is 20, we want to know what the length of this is. And in order to do that, we're going to use the Pythagorean theorem. So we know that 20 squared plus 20 squared equals our, we don't know what this is, c squared. 20 squared plus 20 squared. So what is 20 times 20? What is 20 times 20? Oops. It should be 400 plus 400 equals c squared. 800 equals c squared. That means that the square root of 800 equals c. So this guy right here equals the square root of 800. So now we have this other triangle. So now we have to go from this to a 3D shape where we are trying to figure out what and if our bat can fit inside of our box. So we want to know if that box can hold that bat. That's what we're trying to figure out. So I'm going to give you a visual of that. If I can get it to work real quick. So essentially, we're trying to figure out, I'll turn it this way. We're trying to figure out if we know the length, the length, the width, and the hypotenuse. We know the length, the width, and the hypotenuse. Sorry, my paper's not perfect. We know this. This is what we know. But now we need to figure out if the bat is going to fit this way. So let me see if I can take the glare off real quick. There we go. So we're trying to figure out, we know the length And the hypotenuse, because we have the new leg, we're trying to figure out that hypotenuse right here. So now we're trying to figure out that third limb. I'm going to turn the light back on. I'm going to draw you another box. So here we go. If we have this box right here, here's our box. So now we figured this part out right here, right? We figured out this one because if you think about it, now we need to figure out if the bat's going to fit from here to, draw it a different color. So we're trying to see if that bat's going to fit in the box diagonally. We know this guy and we know this side length because remember this was 20. We figured out that this was the square root of 800. So now we're just looking for this because if I erase this part of the box, we're only solving for that triangle that we're missing from that cuts the box in half. So I don't want to do that too much because I still want the idea of a box. So we're just going to kind of do that. But we want to make sure that we are doing this correctly. So we're going to still use the Pythagorean theorem, but now we're solving for this diagonal. So we have 20 squared plus the square root of 800 squared plus, oh sorry, not plus, equals c squared. So we know that this is 400 plus 800 because the square root of a square is always going to be that number equals c squared. 400 plus 800 is 1200 equals c squared. Square root of 1200 would equal c. That means that the value of c is 34.64 inches. So 34.64 inches. So the question that we had from the beginning of this is, will a 30 fit in a 20 by 20 box? And the answer to that question is yes, it will. It will fit because we know that the total across diagonal of that box, if we look at it this way, if we put our bat in the box, our bat is this white paper, our bat's stuck in there. It's stuck. Maybe see if I can do something. Thought about breaking my pencil. But it's kind of like if the pencil was in the box, like this. So we're trying to figure out how to fit that pencil in the box. That bat's going to fit in the box diagonally. And that means that it is going to fit. So that is what we learned today. We also did the exit ticket. Your job is to do the practice problems, and we will go over them tomorrow in class. So have a great night.